Whenever you try to prove something, you're always doing it using inductive or deductive reasoning. So what's the difference? So let's start with inductive reasoning. That's basically where you notice a pattern, and based on that, you can make a statement about what you think is going to happen next. For example, here I've written down the attendance record of a student in your class. In the first class, he was late. In the second class, he was late. In the third class, he was late, and so on. So based on this, do you think that he is going to be on time or late to the sixth class? Well, it seems reasonable to believe that in the sixth day of class, he's probably going to be late as well, because there is a pattern of this person being late. But there's always a chance that he comes on time. So you can't actually prove that he's going to be late. You're just basing that off of the pattern that seems to show that that's what's most likely going to happen. Whenever you make a statement like this that isn't provable but is based on a pattern, that's called a conjecture. So based on this, my conjecture would be that this student is going to be late for the next class. Now, let's say that on the sixth day of class, this guy shocks the world and comes to class on time. He broke the pattern and therefore proved that the conjecture was wrong. Whenever we can come up with an example that disproves our conjecture, then that's called a counterexample. It's an example that counters what we already said. So as long as you can come up with a counterexample, then that's how you can disprove a conjecture. You can't prove a conjecture, you can disprove one with a counterexample. So here's another example of that in more math terms. So this is my conjecture. X squared is always greater than X. And I think this conjecture is true because it seems like whatever number you put into here, that's true. So like, for example, 2 squared is 4, and 4 is bigger than 2. Or 10 squared is 100. So squaring a number always seems to make it bigger. So based on that pattern, I think that x squared is always greater than x. So you can't actually prove that this statement is true. This is a conjecture. The only way to prove it would be to test it with every single number, which is, there's infinite numbers, so we can't really do that. But we can disprove the conjecture if we can just give one example of this statement not being true, a counterexample. So what could be a counterexample of this statement? Well, all of those numbers that I was showing you were like numbers bigger than 1. But what if we put 1/2 in and squared it? Well, 1/2 squared is the same thing as 1/2 times 1/2. 1 times 1 is 1, and 2 times 2 is 4. So 1/2 squaring it makes it 1/4, which is smaller than 1/2. So this conjecture has just been proven false. All you have to do is show one example of this statement not being true, which is the one right here that I just showed you, and you've disproved the statement. Now, that was inductive reasoning, which is just based on a pattern, but you can't prove it. Deductive reasoning is usually how you actually prove things. With deductive reasoning, instead of showing examples, you take facts, things that everyone knows is true, and if you move these different facts around, you can use them to prove something else. So there are two main laws that we use for deductive reasoning, and these names are going to sound really complicated, but if you think about them, they're actually kind of obvious, and you probably use them in your everyday life without knowing it. So the first one is the law of detachment. Basically, the law of detachment says that, let's say you have an if-then statement. So if this, then that. What the law of detachment says is that if you know that this statement is true, then if you give an example of this happening, then this is also true. I know that sounds kind of confusing, but it will make more sense if I show you an example. So here's an example of an if-then statement. We have if two angles have the same number of degrees, then they are congruent. That is a definition in math that we know is true. That is what congruent means. It means they have the same number of degrees. So let's say I have two angles. One angle is 45 degrees, and the other angle is also 45 degrees. Well, the law of detachment says that because we know this statement here is true, and we know that these two angles have the same number of degrees, then it must also be true that these angles are congruent. So we can use this statement that we know is true to make another statement. Our new statement is that these two angles are congruent. The second law that we use a lot of the time for deductive reasoning is the law of syllogism. So let's say that we have two statements that we know is true. For example, let's say that in my math class, if I pass a test, then I'm going to get an A in the class. And let's say that we also know it's true that if I get an A in the class, then my GPA overall is going to go up. So think about this logically, right? Let's say I pass this test. If I pass this test, then it's going to give me an A in the class. But getting an A in the class is also going to make my GPA go up. So the law of syllogism says that we can make a new statement. This statement is, if I pass this test, then my GPA is going to go up. Because if I pass the test, I get an A, and that automatically triggers the second statement, which is if I get an A, my GPA goes up. So we can completely skip the A in the class part and just say that if I pass the test, my GPA goes up. So again, a lot of these things are just things that you do naturally in your everyday thinking in life, but you didn't know that they had a name. So just relate these with real life examples, and it will be a lot easier to understand that way. So now you know the difference between inductive and deductive reasoning and how to do both of them. And if you're taking a geometry class right now and you're wondering what this is all for, well, it's just one of the steps in preparing you to do proofs. To be able to do proofs, you're going to need to know the names of laws that might seem really obvious, but you still need to name them when you're doing your proof. So there are a lot more different rules and stuff that you need to learn. So if you want to learn 7 more of the most important proof rules, then you can watch this video right here. And as always, if you have any questions about this video, go ahead and leave it in the comments and I'll be sure to answer your question. Thanks for watching.